Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in this video tutorial, we are going to be implementing the queue data structure using a C++ program. So we're going to write a C++ program to implement queue data structure and all the standard data structure operations. And this is sort of like the part 2 under the queue data structure topic. In the previous video tutorial of this playlist, we discussed in theory what is a queue data structure and the different standard operations and how does queue data structure operate. We also saw the applications and we also saw what happens behind the scenes by taking a visual representation on the digital blackboard of how exactly a queue looks like. So if you have missed that video and if you're a beginner, do check that video out. I would definitely recommend you guys to check that video and then come on this video. But if you are just interested in the implementation, that is the programming part, then this video is just for you. Okay, so with that being said, let's get started. And as you can see, I have already opened up my dev C++ IDE wherein I'll be typing the C++ code, and I've already written a little bit of code over here. So here you can see I have created a class named queue. Inside that, in the private section, I have 3 variables, that is 2 variables and 1 array. Okay, and then in the public section, we will be implementing the different operations. Below in the int main function, what I'm doing is I'm creating a menu driven program. So I am using a do while loop. Inside the do while, I'm printing what operation do you want to perform. Now depending upon the option number, so I have options 1 to 7. We will take the option number from the user and we will call the particular action. So if we say 1, the enqueue operation will be called. So case 1 is for enqueue, case 2 is for dequeue, and so on and so forth. So we still have to write the code over here, but I have created the structure already. So what you can do is you can quickly pause this screen over here, type out some of the code over here, and I'll scroll a little bit down if you want. You can copy the switch case also. And then this is the basic main function. We still have to write a lot of code in the main function also, and we have to implement the different operations as methods in the queue class. Okay, so let's start off with the coding part. Now taking a look at the previous video's digital blackboard wherein we discussed the different algorithms. The first thing is the initialization part, and in the initialization part we create an array and we assign the rear and front as -1 and -1. So because the queue data structure has 2 ends, that is the front end, so this is going to be the front end and this is going to be the rear end. There are going to be 2 individual variables which keep a track of the index positions of the front end and rear end. Okay, so initially they are going to be assigned as -1. So that's why what we'll do is first we'll create a constructor over here. So I'm going to say queue. I hope you know what is a constructor. I have a complete separate C++ programming tutorial series for beginners also in our Simple Snippets channel. You can go check that out. I'll drop the link and you can probably see a card on the top right corner. But yeah, let's create a constructor. First thing we are going to do is we're going to say front equals to -1, rear equals to -1, and I'm also going to create a for loop. I'm going to say int I equals to 0, I less than 5 and I plus plus. I'm going to say ARR of I equals to 0. So initially I'm assigning all the values in the array as 0 by using this for loop, simple for loop. Now remember, we can take this size from the user by using the concept of dynamic memory allocation, but we are keeping our program simple. That's why we have given a hard-coded standard size, a fixed size that is. So this is just for representation. You can add on things later on. So this is the default constructor which will be called whenever we create an object of queue in the main function. So in the main function you can see q1, and this default constructor will be called. The front and rear data members of the q1 object will be assigned -1 and all the values in the array for the first time will be 0. Okay, let's move on to the next standard operation of the queue. So we have isEmpty. So let's try to implement that. So this isEmpty operation has a return type of Boolean or bool in C++ because it will return true or false. So I'm going to say isEmpty. Inside that we just have to make a simple check. If front equal to -1 and rear equal to -1, then you have to say return true, else false. So very basic. I'm going to say if front equal to -1 and rear equal to -1, return true, else return false. Because when we create the queue is going to be empty, and the condition for empty queue is front equal to -1 and rear equal to -1. So that's what we are checking in the if condition. Okay, so first operation done. Next operation is bool is full. Okay. So from the algorithm here, what we are checking for is if the rear value, that is the index position value in the rear variable, is equal to the size of array -1. So whenever a new value will be added or enqueued in the queue, the rear value will be incremented, right? So if I insert one value, the rear will be having 0. If I have two values, rear would be having 1. So it is always going to be 1 less than the size of the array, right? So that's why we are checking for size of array -1. So here again simple checking, if rear equal to 4. Now we know the size of array is 5, so that's why I'm directly hard coding 4 over here. Here I'm going to say return true, else we will say return false. Simple enough. Two of the operations are pretty much done. Let's move on to one important operation, that is the enqueue operation. So I'm going to say void enqueue because we don't have any return type, but we have to pass a parameter, that is a value which will be inserted in the queue, right? So I'm going to say int val in the arguments. So here first we have to check whether the queue is full or not. I'm going to say is full. So if the queue is full, I'm simply going to say cout queue is full and we will say return. Okay. So the function will be exited over here itself. Now there is one more condition. If you see the algorithm, we have to check for isEmpty. So when the queue is empty, we know that the rear and front are going to be -1, -1. So we cannot add the value at -1 location because obviously -1 index does not exist. So first we have to make the rear and front as 0. And the reason why we make both the rear and front as 0 is because when we add the first value in the queue, both the front end and rear end of that queue is going to be at that same position, right? So when we add the second value in the queue, at that time the rear end is going to be different, which would be pointing to the second value, and the front end would be different, which will be pointing to the first value. But when we have only one single value, the rear and front are always going to be pointing to the one single value. Okay. So that's why we have to check for else if is empty. So let's check that. I'm going to say else if is empty. If it's empty, first we have to say rear equals to 0, front equals to 0, because we have to increment that from -1 to 0 and 0. And then I'm going to say ARR of rear or front, whatever you want, because it's going to be one and the same, is equal to whatever val that you pass as argument in the enqueue function or enqueue method. Fair enough. So the else if is done. Now in the else part, so the else part is going to be executed when the queue is not full and the queue is not empty also, which means there are some values inside the queue but the queue is not full. So in that case, let's say we already have one value over here. In that case, we just have to increment the rear counter or rear variable, right? Because the front is going to be pointing at the front end, but now only rear has to be incremented. So we are going to say rear plus plus, and we are going to say ARR of rear equals to the new value or val. Okay, so this is pretty much the enqueue function. This is the enqueue function. Over here I have created or kept the ARR of rear outside else and else if is because it is common to both. Over here I have included it inside else if and inside else. You can cut these two things and paste it over here also, but this also will work. Let's move on to the last standard function. Actually there is one more count which is very basic. We will do that after this one. The last one is dequeue function or dequeue method. By the way, when I'm saying function and method, it basically means one and the same. When it comes to objects and classes, if you have a function inside a class, it is termed as a method, but basically it is one and the same. Now the dequeue method has a return type of int. So it's going to be int dequeue because we are removing some value which would be returned, but we don't have to pass any arguments. So here first we have to check if is empty, because if the queue is empty, we cannot return or we cannot remove anything from it, right? So here simply we can copy this code and paste it over here, and here we can say queue is empty, return 0. We have to return some value, right? Because we have the return type of int. The next condition that we have to check is for if front equal to rear. Now when does front and rear always be same? When we only have one value, right? So remember, when we add one value or the first value inside the queue, both rear and front are made 0, 0. Similarly, if there are multiple values and after dequeuing only one value is left, the rear and front pointer will be pointing to that same index location. So this is that else if condition in the dequeue algorithm. You can see front equal to rear, which means that only there is one single value and that value has to be removed, right? Because we are calling the dequeue method. So what we'll do is we'll first create a variable over here, int x. So I'm gonna say x equals to ARR of front. Now we will say rear equals to -1, front equals to -1, and lastly we will say ARR of front equals to 0. I will explain what exactly is happening, and last statement would be return x. Okay, so what exactly happened over here? So let's assume that we have entered one value in our queue. So 5 is entered. Let's say we have 5 over here, and now we are calling dequeue. So here, since there is only one value, both front and rear are going to be equal to 0. So first things first, what we do is in the code we create a temporary variable and store the value of 5 in that variable x. Then we make rear and front -1 because we are going to remove this value off, right? And we have only one value in the queue, which means after removing this, the queue is going to be empty, which means we have to come at rear equal to front equal to -1 state. So this is what is happening over here. Rear and front is becoming -1, and we have to first make this actually over here, ARR of front equals to 0. So before decrementing the rear and front and making them -1, what I'm doing is first I'm storing the value phi, which is at this location in the temporary variable x. Then I'm making that value phi equal to 0 because we are removing it off. And when we say removing it off, we make it 0, right? We have to do something to reflect that change. Otherwise the value will always be there and we will not be able to see the change happening. And then I'm making rear and front as -1 to denote that the queue is now become empty. And lastly I'm saying return x. So x had that value of phi, right? We stored that at the very first beginning over here and then made that value as 0 at the array location. So I hope you are understanding what we did over here. So you can have rear or front because both of them are going to be same over here. So that's okay. So this is that else if condition. This is not that else condition. This is the else if condition. I again made a little syntax error. And lastly we have the else condition. Now the else condition is for the code when we have multiple values in the queue. So in that case what happens is we just say front ++ and remove it off, right? So here I'm gonna say x is equal to ARR of front. We make that value as 0 and we simply increment the front counter and we say return x. So coming to the diagram, if we have two values over here, let's say 5 and 6. So the front is going to be pointing to the first value. So we will store that in the x variable. Then we will make this as 0 and then we will increment the front as 1 by saying front ++. And then we will return that value in the x. Okay, so these are the 4 steps that happened over there. So I hope you are understanding what exactly is the dequeue code. And this is pretty much it. These are the 4 standard operations. The one last operation was left, that is int count. I'm going to say int count. And what it will return is the count of elements currently inside the queue. So that can be counted by this formula. I'm going to say return rear minus front +1. So let's say in our queue we have two values. Okay. So front is going to be pointing to 0, rear is going to be pointing to 1, right? When we have two values. So using that formula rear minus front, so 1 minus 0 is 1. And when we add one more to that, it is 2. And that is exactly the number of elements we have in the queue, right? So again, if we have three values, the front value is going to be pointing to 0. The rear value is going to be pointing to 2. So 2 minus 0 plus 1 would be 3. So at any given point, this formula will give you the exact number of values which are present inside our queue. Okay, so these are the 5 operations: count, dequeue, enqueue, isFull, isEmpty, and then this is our default constructor. So we have pretty much created our queue class. Let's go to the main function now. Now inside the main function, we have created a queue object over here. We will also create an integer variable known as option and one more as value. I'll tell you why we do that. So in the do while loop, we are printing a complete dialog box, an option box, which gives us 7 options. First one is enqueue, second one is dequeue. We have isEmpty, isFull, count, display, clear screen. And here you can see we have to enter 0 to exit. So in the switch case, or basically in the do while loop, so in the while condition, that is the do while condition, what I've said is if option not equal to 0, you keep on executing this do while loop. So this means that this code is going to be executed over and over again until and unless we do not enter 0. So here we are taking that option from the user, so that's why we created this option variable. Now we are passing this option in the switch case for these 7 different operations. So for case 0, we have to break out from the switch case. We have to come out from the do while loop. So we only have one statement as break. In the case 1, we have to do enqueue. So let's call enqueue. So here we have 3 statements. First one, we print a message enqueue operation, enter an item to enqueue in the queue. Then we take that item from the user, that is take that value. So that's why this value variable we created at the top in the int main. And then we say q1.enqueue. We have created the q1 object over here. We are saying q1.enqueue and we are passing that value. Simple enough. This is case 1. Case 2 is dequeue. So let's see that dequeue operation. So dequeue is even much more simpler. We are just saying dequeue operation called, dequeued value is q1.dequeue, and that's about it. Third option is isEmpty. Again, simple enough. Here we are checking if q1.isEmpty, we print q is empty, else q is not empty. Similar to that, fourth option is isfull. We check for q1 is full. If it is full, we print q is full. If not, it is not full. Remember to add break statements after every case. Otherwise, the rest of the cases will also be executed and that can create an issue. Case 5 is the count. So I'm printing a message count operation called and count of items. So this /n is new line, okay? I hope you know this. /n would be taking the output on the new line. And then I'm saying count of items in queue is q1.count. Simply calling the methods, pretty basic. The sixth one is display. We have not created the display method over here. Now the display will actually just print out all the values in the queue. So let me just quickly just copy paste the code because it is simple for loop and printing the output from int I to I less than 5, and then I'm just printing out the array. So all values in the queue are, and then in the case 6 we have to just actually say display function called and print out the values. Okay, and the last case is a special case which we want to use to clear the command prompt. So remember in Turbo C++ we used to do CLR SCR to clear the command prompt. So here we have to do, or we have to call a system function and it's known as system, and we have to pass CLS. So this is the default way to call or clear the command prompt. Okay, so yeah, this is pretty much the entire code, and let's save this and let's see if this runs. I think it would give some error, but let's hope that it runs perfectly fine. I'm gonna say compile and run, and we are getting an issue. Okay, we have forgotten to mention the default case. So this one last thing was left out. So if some invalid option number is entered, so you have options from 0 to 7, right? We have 0 case till 7. But what if someone enters some extra value or some invalid option number? So in that case, we will print enter proper option number. Simple enough. Okay, let's again save this and let's try to compile and run. Okay, our program ran successfully, and I'm kind of shocked because many times I get error in the first 2 runs. But yeah, let's first do a display. So for display, you can see we have to select option number 6. I'm gonna say 6 and hit enter. And there you go, display function called all values in the queue are 5 times 0. Because initially when you create a queue, in the default constructor, we make all the values as 0, right? So that denotes that the queue is empty. Okay, so the next thing is let's do option number 3. Let's check if the queue is empty. Right now it is empty, so we should get that. So I'm gonna say 3, hit enter, queue is empty. So this is exactly what we want. I'm gonna hit 7, which will clear the command prompt. And again, the option is again printed because the do while loop is running. If we enter 0, only then this program will be exited. So now let's do an enqueue function. I'm gonna say 1. It's asking enter an item to enqueue in the queue. I'm gonna say 5. Hit enter. I did not print any prompt over here saying value entered. You can add that. But to see if the value is enqueued in the queue, let's do a count. So I'm gonna hit 5. Option number 5 is for count. And there you go, count operation. Count of items in the queue is 1, which means that 5 was entered. And to again verify it, I can use the display. I'm gonna say option number 6, hit enter, and there you go. At the front end of the queue, we have 5. So values are entered from this end, and this is the front end. And right now this is also the rear end also, because when we have only one value, the front and rear will be same. Now let's again check for isEmpty. So I'm gonna say 3, isEmpty. Now you can see queue is not empty because we have one value. Let's do one more enqueue operation. I'm gonna say enqueue operation. I'm gonna say 4, and I'm gonna say display now. we should have 5, 4 and then 3 times 0. And there you go, you can see 5, 4 and 3 times 0. So I'll add 3 more values, 3 more enqueue operations. I'll enter 3. Again, one more enqueue operation, I'll enter 2. Again, one more enqueue operation, I'll enter 1. Clearing the screen and again calling the display. 5, 4, 3, 2, 1. So now if I try to enqueue one more, I should get a prompt of isFull, right? So if I hit enter and if I try to enter new value as 9, I'm getting queue is full, which means our isFull method is working perfectly fine. That condition and algorithm is working fine. Let's clear this. Now we will do dequeue. So I'm gonna say 2 and there you go, dequeue operation, dequeued value is 5. So the first value that was entered was 5, right? So that is what comes out, first in, first out. Now if I say display, there you go, you can see the first value has become 0 because we made it 0 in the dequeue operation, and now we only have 4, 3, 2, 1. I'll just clear this screen, again call display, and now if I say count, the count should be 4, not 5. Okay, I hit the wrong option number, I'm gonna say 5. And there you go, count operation, count of items in queue is 4. So we have 4, 3, 2, 1, that is 4 items, so that's why we're getting 4. Again, I'm gonna clear the screen. Let's do one more dequeue. Dequeue operation, dequeued value, the 4 value was called off. So if I do a display now, we have 5 also removed, we have 4 also removed, we are left with 3, 2, 1. So remember, values were added from the rear end, that is from the right hand side, and now they are being removed from the left hand side, from the other end. That is in a first in, first out way. So if I just clear this and display it again, now if I do one more dequeue, 3 should be removed, right? So let's do that. Hit 2, dequeue value 3 is removed. Perfectly fine, everything is working. Let's do one more display. Let's do a count. Count is gonna be 2. So count of items in queue is 2. That is 2 and 1 are left. So one last thing that I wanted to talk about is one drawback which this simple queue data structure has, and that is right now if you see, our queue has 3 vacant locations. So we only have 2 and 1. So basically our queue is empty, right? It is not full. But if you see, if I hit 4, option number 4, that I'm checking if the queue is full or not. If I hit enter, you can see that I'm getting an output of queue is full. So why does this happen? So this is happening because when we did the enqueue operation 5 times, the rear value was incremented from 0, 1, 2, 3, 4, right? But it was never decremented back. And in the isFull operation, we just check for the condition whether the rear is equal to 4, right? So this is the code for isFull, rear equal to 4, which is exactly what is happening in this case. When you are doing dequeue, we are incrementing the front pointer, not the rear pointer, right? So initially, when we did not dequeue anything, we had 5, 4, 3, 2, 1 over here. Front pointer was pointing to the first location, that is 5, and rear pointer was pointing to the last index value, that is this one. But as soon as we did the first dequeue operation, this value was made 0 and front pointer was incremented. However, the rear pointer remained the same, right? So here you can see that with every dequeue operation, the values from the left are remaining useless because we cannot use them now. Because the pointers, that is the variables, front and rear are only incremented in one single way. So every time with every dequeue, one value is being useless on the left hand side, correct? So only when you dequeue all of these values, only then, once the entire queue becomes empty, then the front and rear will be made -1, right? And that happens where? In the dequeue operation. So let's say if I do one more dequeue, hit enter, dequeued value is 2, this 2 is also removed. If I do a display now, only one value left, right? So now this else if of the dequeue will be called because front and rear are pointing both at this location. So once this value is removed, we will make rear and front as -1 and they will go back to this location. So if I do one more dequeue, this value is removed. If I clear screen, if I hit 6, now all of them are 0 and now again front and rear have become -1 over here, you can see in the code also. Now if I do isEmpty, I'm getting queue is empty. So again now I can start off enqueuing values. But you can see that when some of the values are dequeued from the left hand side, that is from the front end, those values cannot be added on. You cannot add on in between. So that problem can be solved using a circular queue, and we will see the program on circular queue and the concept of circular queue in further videos as we move ahead. But this is one important drawback that the basic queue data structure has that I wanted to show you over here. Okay, so this was the entire implementation part of the queue data structure. We wrote the complete program and implemented all the standard data structure operations of queue data structure. If you have any queries, you can always put them in the comment section. If you like this video, please give it a thumbs up. Let me know in the comments that you understood this concept, and do share it with your friends also. This is very important to understand. And if you haven't yet subscribed on the channel, make sure you subscribe so that you get notified whenever I upload a new tutorial video on this channel. So thanks for watching. See you guys in the next one. Peace.